until a measurement forces the system to choose a single outcome and collapse the wave function. But what constitutes a measurement? When does the transition from quantum possibility to classical actuality occur? The mathematics of quantum mechanics describes the evolution of superposition states with perfect precision. But it provides no clear mechanism for explaining why or when superposition ends and definite outcomes emerge. Some interpretations suggest that consciousness itself plays a fundamental role in collapsing wave functions. That observation by conscious beings is what transforms quantum possibilities into classical realities. If this is true, then consciousness isn't just an accidental byproduct of complex matter. It's a fundamental force in the universe, the mechanism by which potential becomes actual, the process by which reality chooses itself from among infinite possibilities. But this raises disturbing questions about what happens when consciousness disappears. If conscious observation is necessary to collapse wave functions and create definite outcomes, then what happens to the universe when the last conscious observer dies? Does reality revert to pure superposition, existing in all possible states simultaneously, with no mechanism to choose between them? Does the universe become a ghost of itself, a shadow realm of pure potential with no actual events, no definite outcomes, no concrete existence? The fine-tuning problem reveals another layer of cosmic mystery. The fundamental constants of nature, the strength of gravity, the speed of light, the mass of the electron, the rate of cosmic expansion appear to be precisely calibrated to allow for the existence of stars, planets, and life. If any of these constants were even slightly different, the universe would be a sterile wasteland where atoms couldn't form, stars couldn't shine, or galaxies couldn't coalesce. The margin of error is so small that it suggests either incredible luck or deliberate design. But fine-tuning raises paradoxes about causation and purpose. If the constants were set by some kind of cosmic designer, who designed the designer? If they resulted from random chance, how do we explain the extraordinary improbability of getting values that permit complexity and life? If they're the result of natural selection among multiple universes, with only life-permitting universes surviving to be observed, then what mechanism creates and destroys universes based on their life-supporting properties? The anthropic principle attempts to resolve these questions by noting that we can only observe universes where observers like us can exist, making our observations of fine-tuning inevitable rather than mysterious. But this reasoning leads to uncomfortable conclusions about the nature of existence and observation. If we exist only because we exist in a universe where existence is possible, then our presence doesn't require explanation. It's simply a tautological necessity of being conscious beings in a universe that permits consciousness. Yet, the anthropic principle raises new questions about the nature of possibility and necessity. If our universe is fine-tuned for life, are there other universes fine-tuned for different kinds of existence? Could there be realities where the dominant form of complexity isn't biological life, but something else entirely? Electronic consciousness, crystalline intelligence, or forms of awareness so alien to our experience that we lack concepts and words to describe them. The multiverse might contain not just variations on familiar themes, but entirely different categories of existence, alternative forms of reality that operate according to principles we've never imagined. The information paradox of black holes reveals fundamental contradictions between quantum mechanics and general relativity. According to general relativity, information that falls into a black hole is lost forever, crushed out of existence at the singularity. But quantum mechanics insists that information cannot be destroyed. It can be scrambled, encoded,